Welcome. We're still in the trigonometric series questions for grade 11. We have simplified the following to a single trigonometric ratio. The first question is sine into 360 minus x must 10 into negative x all over cos into 180 plus x times into sine squared x plus cos squared x. In this kind of question, as we are simplifying, we have to apply the identities. So let's memorize trig identities. You play around with the trig identities. The first is when you have the tan of an angle is the same as sine of that angle divided by cos of the angle. And the second identity that we use, it's sine squared x plus cos squared x. This is the same as 1. So this, in the reduction formula, we have the cast diagram. In the sine 360 minus fourth quad, the sign is negative. So it's negative sine x multiply 10 into negative angle. So these are negative angle and it's in the reduction formula. So remember, always when you have the smallest angle, in that angle you add 360. When you have the biggest, you minus the 360. So in the case like this, this is the same as 360 minus, and now this is the fourth quad, whereby the 10 in the fourth quad is negative. So it's negative 10 of x. 180 plus, it's third quad, cos in the third quad is negative. So it's negative cos x multiply into sine squared x plus cos squared x. We said this is one of the identities. So this identity is equated to 1. So this is the same as 1. Negative times negative definitely is going to give us positive. Therefore, we'll have the sign as positive and 10 as positive. Negative cos x multiplied by 1 is negative cos x. There is a 10 that we can change and apply its identity. The identity of 10, we said it's sine x over cos x. So now we keep the sine x multiplied by the 10 is sine x divided by cos x, the all over negative cos x. Sine x multiplied by sine x will be sine squared x. We keep the denominator of cos x. Allow me to rewrite all over in a division form, negative cos x. Change the division sign to multiplication. This is over 1 that is invisible. Then the reciprocal will be 1 over negative cos x. Sine squared x times 1 will be sine squared x. Cos x multiplied by negative cos x is the same as negative cos squared x. With the 10x is the identity of sine x over cos x. So now we have sine squared x over cos squared x. So this is still the 10, but now the 10 is squared. So the final answer will be negative 10 squared x. So in short, always in this kind of question, you have to try by all possible means to apply the identities where it's applicable. Let's move to the second one. Simplify without using a calculator. We'll try by all possible means to apply the reduction formula. It's cos into negative 210, 25. This is the smallest angle that we have. As said in the previous value, if you have the smallest value, in that smallest angle, you have to add 360. Sine of 135. Choose the 135. It's on the second quad, so it's 180. The value that will give us 135 when you minus to 180 will be 45. Sine of 330. 330 is at fourth quad, whereby we use 360 minus. The angle will be 30. The 10. The 225 is at that quad, so that quad reduction is 180 plus. To get 225, we'll add 45 degrees. Negative 225 plus 360 will give us 135. So 135, we already have the reduction of the 135. It means now we have the cos of 180 minus 45. And this 180 minus is at second quad, whereby the cos at second quad is negative. So it's negative cos of 45 degrees. Multiply. The sine at second quad is positive, so positive sine 45 degrees plus 360 minus fourth quad, sine at fourth quad is negative into negative sine 30 degrees. 80 plus its third quad, sine at third quad is positive. We have the 10 of 45 degrees. In short, you can just write as it's negative cos 45 times sine 45. Negative times positive is negative 30 degrees. 10 45. These are special angles. So the cos of 45, the cos is adjacent over hypotenuse. It's negative 1 over 2. The sine is the same as opposite over hypotenuse. It's 1 over root 2 minus the sine of 30. Opposite over hypotenuse is 1 over 2. Divide by the 10 of 45. Its opposite over adjacent, of which is 1 over 1, and 1 over 1 is 1. Negative 1 over root 2 times negative 1 over root 2 is negative 1 over 2 minus 1 over 2. All divided by 1 would be negative 1 over 2. So the difference of the two is negative 1. 3.4. Prove the following identity. We have the left hand side equated to right hand side. So definitely we can't prove the right, it's equal to the left. So we have enough information on the left hand side to prove the right hand side. So it means we'll use the left hand side. That is, definitely apply the trig identity. What we can do, we have sine x minus cos x all squared. So this is simply means this thing multiplies itself twice. Then we keep the minus 1. The denominator for now will keep as sine squared x minus 1. Multiply the brackets. It's sine squared x is minus sine x cos x. Even if you can say minus cos x sine x, it will be the same because they multiplies. Then it's again minus sine x cos x. Then negative cos times negative cos is positive cos squared x. Then we keep the minus 1, all divided by sine squared x minus 1. Positive sine squared and the positive cos squared. Let's group. Let's sine squared x, we group with the cos squared x, understanding that this is the trig identity. Negative sine x cos x minus sine x cos x is minus 2 sine x cos x. Then we keep the minus 1. This is sine squared x minus 1. This is sine squared x plus cos squared x equated to 1. So we can manipulate this formula. If we want to have sine squared x, can make the sine squared x a subject of the formula by transposing the cos squared to the side. If you want to have the cos squared x, it means the cos squared x is 1 minus sine squared x. We have the sine squared x minus 1 is similar to 1 minus sine squared x. So we have to write this in the form of this. So it means you have to take out the negative as a common factor. Well, negative into, we said cos squared x is 1 minus sine squared x. Sine squared x plus cos squared x is the identity 1 minus, keep 2 sine x cos x, we keep the minus 1, divided by negative, we said 1 minus sine squared x is the same as cos squared x. 1 minus 1 is 0, therefore in the numerator we'll have negative 2 sine x cos x divided by negative cos squared x. So a negative divided by negative is positive. This cos will divide with 1 cos over there. 2 sine x over cos x. 2 divided by sine x over cos x. We said sine x divided by cos x is the identity of 10x. Therefore, this is 2 10x. The final. The question was to prove if the left-hand side is equal to the right-hand side. Indeed, we worked with the left-hand side and it has 2 10x. So we can therefore conclude that the left-hand side is equal to the right-hand side. Thank you and bye. Please don't forget to subscribe, like, comment and share.